BGP gives us the flexibility to define routing policies and modifying attributes to influencing the routing within the BGP environment. We'll now see how we can use route maps to apply BGP route policy and also perform filtering in BGP. The routing policy can be influenced using various attributes which are available with BGP, such as ASPath, local preference, community values, which are specifically user-defined, prefix list, and any other attribute that you are trying to influence using route maps or various other tools. Examples are you can select which routes you want to be advertised or you want to be rejected from being advertised to the remote peer. You can also perform filtering on the inbound side of the BGP neighbor. Say for the remote BGP neighbor is advertising 100 prefixes. Out of those 100 prefixes, you only need 50 of them in your network. You can use the route policy mechanism to filter those prefixes and allow them from entering or getting installed in your routing table and getting advertised throughout your network. You can also use various attributes to influence the path selection algorithm. This is what we saw in the last demo we did in lesson 7. We'll now see how we can use route maps with BGP. Route maps are not just used for applying attributes to the path and influencing the path selection algorithm, but also helps in modifying or filtering the route policies. You can use it with route advertisements. You can use it with inbound and outbound route filtering based on a network statement or based on a neighbor configuration. The route maps can also be applied on peer groups or on a per neighbor basis. Based on how you're applying inbound or outbound direction, the actions can be performed by the route map. In the route map, you have both the match and the set operation. Let's now see how the route map actually functions in Cisco IOS. The route map has 4 major components: sequence number, processing, where you have the action of permit or deny, conditional matching, and optional action. It's not mandatory you set an action or perform a set operation on a particular match criteria. Conditional matching criteria helps you perform various actions on certain attributes itself. Say you want to set local preference for the prefixes in a particular range of subnet. You can use the match criteria to perform that action. You can use the action component to perform the set operation. We'll now see the route map rules on Cisco IOS devices. The route map works in a way of if and else criteria. If you have a particular route map statement, say for route map XYZ permit 10, and you perform a match and set option operation, then it exits the route map after performing that action. If the match criteria does not follow or does not match, then it moves to the else if criteria, says if else if match and then set and exit the route map. If it still doesn't match and you have further entries, it performs again else if. If there are blank route maps, it means match everything and set nothing. So if you are having a blank route map statement, it will permit everything which is not matching in any of the other route map entries. Let's now have a quick example in the lab to see what I was speaking about so far. Let's go into the config mode on router AS100 and see how we can influence the route advertisement using route map. We go into the config mode, we create a route map, name advertise, and say permit 10. You can always set an option instead of permit, you can also set deny, but we can say permit 10. If you do not specify permit 10, it will automatically set it to permit. The 10 or any other number following the permit or deny statement is the sequence number of the route map entry. It always go into an increment of 10 steps. So in the route map, we configure the match criteria, match, IP, address, prefix list, and we name the prefix list, say, subnet. And we do not perform any set operation. And we exit the route map, and IP, we configured the prefix list. IP prefix list subnet permit 100.1.1.0/24. Now, what we can do is we can apply this route map on the outbound direction of the neighbor towards AS200 router. We go into the router configuration mode, router BGP 100, address family IPv4 unicast, neighbor 10.1.102.2, route map advertise out. And we can see now what prefixes are being advertised towards AS200. So we can run the command show BGP IPv4 unicast neighbor 10.1.102.2. So here we can see that prefix 100.1.1.0/24 is being advertised towards the neighbor in AS200. But the question is, we only matched 100.1.1.0/24. Remember, I made a statement saying if there's an empty route map entry, means match everything. But do we have an empty route map entry? Let's check it out. If you look at the route map configuration, show run pipe section route map, we do not have any second statement after the permit 10. There's only one permit statement, so it is not matching any other prefixes. Remember, if you do not have a following sequence entry after the match criteria, everything will get denied. If you have an empty entry, means everything is permitted. So we'll now go ahead and configure the permit 20 statement. We go into the config mode, we copy and paste the same command and name it sequence 20. And we just leave it empty. That means there's no match and there's no set statement. We go back, we do an end. We'll now look at how the advertised routes look like towards the AS200. We run the command show BGP IPv4 unicast neighbor 10.1.102.2 advertised routes. And we can now see both the prefixes are being advertised. The reason for the second prefix 100.1.2.0/24 being advertised is the empty route map statement that we configured. So while troubleshooting routing policies and when you're applying new policies in your network, ensure that you have a permit statement or an empty route map entry at the end. If you forget to add the entry on the configuration, you might run into a situation where the prefixes are not getting advertised. Under the route map, there are different match criteria. You can match on AS path, you can match on community list, you can match on interface, IP addresses, next hop values, route source, length of the prefix, metric, route type, and tags. Tags are one of the common ways, similar to community list, where you can set a tag on a prefix and match tag on the other side. Based on the match criteria, you can perform different set operations on the route map. You can set an AIGP metric, AS path, automatic tag, community value, default interface. You can set the next hop for the prefix. You can set the level, local preference, metric, or set any other attribute for the prefix. Let's now have a look at the sample configuration of route filtering using route maps. Notice that there's a route map named filter on AS path with permit statement sequence number 10. You're matching on AS path 1, that is the AS path list. The AS path list is configured at the bottom of the configuration where it says IP AS path access list 1 permit $2120. What this regular expression means here is you want to match a prefix which is originating from the AS number 2120. Similarly, you have another route map entry with permit sequence number 20 saying just the match statement, match AS path 2. And you have the AS path access list 2 with the regular expression _3561 _. What that means is you want to match a prefix which is passing through the AS number 3561. Remember, in the previous example I mentioned, if you do not have a default or empty permit statement after your match statements, no other prefixes will be permitted. And thus, if you are having a filtering configuration over here, so you have configured the filter on neighbor 10.1.12.2 route map filter on AS path in on the inbound direction. So all the prefixes which are matching the criteria in permit 10 statement and permit 20 statement will be allowed, and all other prefixes which are not falling under any of these sequences will be denied. This is how you can apply filtering using route maps. The way of configuring route maps is similar on Nexus devices as well, similar to what we have on iOS devices. It is a bit different in ISXR. We'll now take a look at it.